Assalamualaikum to my fellow panel. Today I will present about my final year project too. So the title of this project is Investigation of Varactor Diode for Frequency Selectivity in Wireless Communication. My name is Siti Nabila binti Rahim with matric number DE180121. For the introduction part, I will explain briefly about the definition of varactor. So, varactor diode is a semiconductor device that functions as voltage variable capacitance or tuning element. It is act as switching components to ensure the tuning functionality of reconfigurable antenna. Varactor diode operates in reverse bias mode where the PN junction has crossing capacitance CT. The advantages of varactor diode is higher switching speed, better stability, and lower applied voltage. This is the symbol of varactor diode. As you can see, the diode has a parallel plate capacitor. So next, reconfigurable antenna mechanism has 4 types, which are electrical, mechanical or physical, optical, and material changes. In this project, I only focus on electrical as varactor diode is used for switching components. Basically, a reconfigurable antenna can measure the radiation performance of multi-antenna system that utilize a dynamically adjustable configuration. It also allows tuning of frequency range and radiation pattern in the desired direction. So the problem statement is the massive growth in the number of subscribers has led many cellular networks being overlapped that effectively support a huge group of users. Therefore, the reconfigurable antenna have advantages of compact design and able to produce wireless standard and multifunction capacitance. The tuning of frequency resonance is achieved by changing the effective antenna electrical properties by integrating of varactor diode. So this project is proposed to investigate the property of varactor diode that would serve the purpose in reconfigurable antenna. The objective of this project has slightly changed from FYP 1. So the first objective is to investigate the performance of varactor diode through its electrical characteristic analysis by using computer simulation. The second objective is to design the antenna that match the targeted operating frequency in wireless communication. For scope of this project, there are some additions from FYP2, which are the targeted operating frequency using varactor diode is 5 GHz, which is for bandwidth for wireless local area network WLAN application. Next, the antenna output parameter that being investigated is reflection coefficient and antenna pattern. The methodology part is remaining same. First of all, I will define the device technology that is suitable for wireless communication, and next I will determine the related formula that describe all the characteristics. And after that, the experiment is being done in simulation work in MATLAB, and after that I will analyze the simulation data. After that, I will benchmarking the simulation data with the theoretical background, and finally examine the frequency reconfigurable for wireless communication. There are 3 main parts of electrical characteristic that being investigated in this project. Firstly, the capacitor voltage characteristic. Second, the resonant frequency, and lastly, doping concentration and doping width. This is all the related formula that has been collected from research paper. Okay, this is the formula for antennas dimension. There are 2 antennas that have been designed and simulated in MATLAB, which is microstrip patch antenna and microstrip inset fed antenna. The purpose of designing this reconfigurable antenna is to investigate the reflection coefficient for resonant frequency range and radiation pattern of the antenna. Both antennas are optimized to work in the WLAN application bands, which the targeted frequency is 5 GHz. This table shows the parameter value for designing the dimension of antenna. All these parameters is being calculated using related formula that I already explained just now. As you can see, the slot in this antenna is also known as feed, which can be replaced by a varactor diode. In designing this antenna, the location of varactor diode play a major role in tuning the resonant frequency. So, different antenna design has different location of the slot. This is the schematic diagram for microstrip patch antenna, and this is the diagram for microstrip inset fed antenna. Okay, for the result and analysis, this is the related formula to simulate the CV characteristic. The results show the nonlinear capacitance curve is inversely proportional to the reverse bias voltage of Varactor diode, which is varying from 0 volt until 15 volt, 14 volt. It could be compared with the theoretical curve where the operating voltage of 15 volt it give 13 picofarad, which is quite familiar with the value of capacitance from simulation result. Next, to illustrate the resonant frequency, I use this formula which is implemented using LC circuit from equivalent circuit. In this experiment, I used two different values of capacitance in order to compare the resonant frequency based on the selective capacitance value. It also could be said the small uses of capacitance can tune a wide resonant frequency. Next, doping concentration is important parameter in Varactor diode because the doping level is depending on the tuning range of Varactor diode. So the simulation result indicate that the magnitude of impurity concentration is uniformly by the thickness of doping width, where the value of doping distribution is 1 to the power of 16 cm per cube. Both value from theoretical and simulation are slightly different due to the material type used in Varactor diode. However, the pattern of impurity concentration decrement over the doping width increment has been verified. Okay, in the MATLAB software, I already simulate the microstrip patch antenna. So this is the 3D view of antenna. It has two metal, which is ground plane and the top patch. This is the location of slot, which can be replaced by Varactor diode. And this is the value for each parameter for antenna dimension. It has patch length, width, height, ground plane length, ground plane width, and the feed offset. Feed offset means the location of a slot. So this is the parameter for substrates patch antenna. Okay, next I will simulate the S parameter, which is the reflection coefficient. So from this graph, the reflection coefficient is negative 23.31 dB at the 5 GHz frequency, which is good for reconfigurable antenna properties. It also can be confirmed that this microstrip patch antenna can reach the targeted frequency of 5 GHz using Varactor diode as a feed. Okay, next I will simulate the elevation radiation pattern. From this elevation radiation pattern, it shows the gain peak at 90 degree is 9.805 dB. Besides that, the gain at 180 degree is negative 25.36. It shows the null is high due to the high gain. Null means the signal strength of antenna is minimal or weak. Next, for the microstrip inset fed antenna, this is the 3D view for antenna design. It is same with the microstrip patch antenna, which is it has two metal, ground plane and patch plane. The difference for both antenna is the location of slot, which is for microstrip inset fed antenna. The Varactor diode can be replaced at the slot which is located at the edge of the inset fed. So this is the value for each parameter for microstrip inset fed antenna. As you can see, it has notch length and notch width. So this is the parameter for substrate patch antenna. For microstrip inset fed antenna, the impedance is 30 ohm. So next I will apply these properties. Okay, next I will simulate the S parameter, which is reflection coefficient for microstrip inset fed antenna. So from this graph, the reflection coefficient is negative 15.26 dB at the 5 GHz, which is lower than S parameter of microstrip patch antenna. Therefore, microstrip patch antenna show a reasonable improvement as compared to this microstrip patch inset fed antenna, where the location of Varactor diode play a major role in tuning the resonant frequency. In addition, the dimension for both antenna also play a major role in determining the magnitude for the targeted frequency. Next, I will illustrate the elevation pattern. From this elevation radiation pattern, the stronger beamwidth, which is 90 degree, has a gain peak 9.59 dB. Besides that, the gain of negative 17.35 dB at 180 degrees shows the null is low compared to the microstrip patch antenna. So in the conclusion, non-linear capacitance curve is inversely proportional to the reverse bias of varactor diode voltage, which is varying from 0 volt until 20 volt. Next, the resonant frequency can be analyzed based on the selective capacitance values, where small value of capacitance give a wide range of resonant frequency by varying the reverse bias voltage of varactor diode. Finally, using a varactor diode as a feed, it can be verified both antenna are successfully addressed for investigating the reflection coefficient and antenna radiation pattern at the targeted frequency of 5 GHz. So that's all from me. Thank you.